Assalamualaikum. Hi, in this video, we will see the mechanism of alkylation of benzene for secondary or tertiary haloalkane, where we will form the electrophile in a form of carbocation. So let's see the example here. Okay, so basically we have benzene react with this secondary haloalkane. How do we know that this haloalkane is a secondary haloalkane? It just like we do how to recognize the primary carbon, secondary carbon, and so on. Okay, we can see the halogen here. Okay, and this carbon, okay, carbon that attached to the halogen. Okay, let's see how many other carbons that been attached to this carbon. Okay, so we can see this carbon, you focus on this carbon because this carbon is attached to the halogen. Remember the haloalkane, halogen, this carbon. So see how many other carbons that attach to this carbon. The carbon. Okay, so we have 1, 2. 2 other carbons that attach to the carbon bonded to the chlorine. So that's why it is secondary haloalkane, because we have 2 other carbons that bonded to this carbon. Alright? So basically what happened is this secondary haloalkane, it will substitute with one of the hydrogen here to form this alkyl benzene. So remember that this carbon, okay, because initially we will break this bonding, this carbon will be attached to this here, this one. Okay, it will be, this carbon will be substituted to this hydrogen. You can see here, this carbon, not this carbon or this carbon bonded to the carbon at the benzene ring. This carbon, remember, carbon that attached to the halogen, because this carbon will later form the carbocation. Alright, so step 1, let's see step 1. Sorry, it's still moving. Okay, in step 1, can you see the video clearly? I hope so. I think it's clear, right? Okay, step 1, okay, same with the previous mechanism or in previous reaction. The first one is formation of electrophile. And as I discussed in the previous video, this time around we will form the electrophile in the form of carbocation. Why? Because we have the secondary haloalkane. Remember, for Friedel-Crafts alkylation, if we have secondary or tertiary haloalkane, then definitely we will form the electrophile in the form of carbocation. Okay, for the mechanism here, the secondary haloalkane, the chlorine here, okay, this is a polar pipe, electron rich here. It will attack the Al to form this kind of complex. Okay, to form this kind of complex. This, it will attack the Al, so we'll form a bonding here between this Cl over here. It will bond it to Al. Can you see that? However, this kind of complex is unstable. So what happened? This bonding, okay, this bonding between carbon and chlorine here from the haloalkane originally, this will be break. This bond will be break heterolytically, and the electron will be transferred to the chlorine because chlorine is more electronegative than this carbon. So therefore, we will form this carbocation. We break this bond, electron goes to the chlorine, so that carbon will form a positive charge. This accept the electron, and here is the electron. Okay, we have 2, and then we break the bond, goes to the chlorine, and it get back the lone pair. Okay, so here, this is what we want, the carbocation, and this is a secondary carbocation. Okay, a kind of stable carbocation. So basically, this is how the carbocation looks like. Hydrogen, we have 1 CH3 here and 1 CH3 here. So this is a secondary carbocation, right? 1, 2. attached to the C+, secondary carbocation. Secondary haloalkane will form secondary carbocation, a more stable carbocation. Because we are forming a quite stable carbocation, that's why in step 1, the electrophile will be in the form of carbocation. Because we can form a quite stable carbocation. That's the reason why we form carbocation. Okay? Okay, for step 2, okay, formation of the arenaceous ion. Okay, in step 2, basically, this benzene ring will attack the carbocation. Now, the benzene ring acts as a nucleophile and the electrophile. The carbocation acts as electrophile. Okay, so what happened is, okay, the double bond here reach in electron. This is the nucleophilic side. It will attack the carbocation. Remember, it will attack particularly at this carbon that has the positive charge, the carbocation, not this carbon. Okay, the double bond, the nucleophilic side will attack to the carbocation, this particular carbon. Alright, when this double bond attack to this carbocation, therefore we will form a new bond between this carbon, okay, because the double bond is in between this carbon and this carbon, right? Therefore, the bond will be formed here. The benzene ring, the carbon here, will form new bond with the carbocation just now. Alright, and then when we attack this double bond to this carbocation, therefore the double bond here will lose its electron because it's already formed the new bonding with the carbocation, and that makes this carbon, okay, the other carbon, will be a positive charge, and then this is what we call an arenaceous ion. And the delocalization of the pi electron will happen here. Okay, how it will happen? So this double bond, okay, will be delocalized in between these two carbon. Therefore, we can see a new pi bond form here. Okay, because this electron from the pi bond move to this bonding between these two carbon, and we form new double bond. Therefore, what happened to this double bond? It will lose its double bond, and this carbon, okay, it lost its electron and become positive. Okay, and then the double bond here will do the delocalization of electron once again. Okay, it will move in between these two carbon, okay, to stabilize the positive charge just now. Okay, and what happened next is when we move the pi electron to this kind of bonding, meaning in between these two carbon, we will form a new double bond here. Can you see the pattern? Okay, and therefore this carbon will lose its electron and form a positive charge. Okay, I hope you can see that. So basically, this is the arenaceous ion that can undergo delocalization of the pi electron around the ring, and they will form 3 resonant structures. Okay, one other thing is, remember when we attack this nucleophile to the carbocation, okay, remember before the reaction occur, okay, actually each of the carbon in the benzene ring, okay, has 1 hydrogen in the carbon. Am I right? Okay, so now when this double bond attack the carbocation, we form this new bond, and this hydrogen is still there. And that makes the positive charge just now. Alright, so you can see that formation of arenaceous ion in step 2. And finally, step 3, the loss of proton. Now, what happened is in step 3, in the final step, we want to remove this proton or this hydrogen. Why? Because we already know that in benzene, the type of reaction occur is the electrophilic aromatic substitution reaction. It's just a substitution reaction. We substitute this hydrogen with this alkyl group from the haloalkene. Okay, so we will remove this hydrogen to stabilize back the ring, the benzene ring. So to remove the hydrogen here, what happened is we will use this compound or this molecule that we've already formed in the first step just now. Okay, just refer back to your first step. This is your first step. Remember, in the first step we form the carbocation as well as this thing. Okay, so in the final step we are going to use this kind of complex or molecule here to remove the hydrogen ion. Right, it's here. Okay, so what happened here? This bond will be break. Okay, the electron goes to the chlorine to form the chloride ion, and then the chloride ion will attack the hydrogen here. Okay, and then therefore this hydrogen carbon bonding will be break, and the electron goes back into the benzene ring here. So that's why we will form the double bond back here, and it become a benzene ring as usual. Okay, so now we can see the product, there is no more hydrogen. We only left the alkyl group. The hydrogen is removed already. Okay, and therefore we also form the side product HCl and AlCl3. Why? We can see that when we break this bond, okay, we want to break this bond, the electron goes to the Cl, right? So we already form back the AlCl3 as the Lewis acid or as the catalyst just now, and this chloride ion attack the hydrogen. Okay, so it will form HCl. Okay, so basically that is the 3 steps for the mechanism for Friedel-Crafts alkylation.